Assalamu alaikum viewers. Now we will discuss the topic of ionization energy. Now we will discuss the definition of ionization energy. The amount of energy required to remove the electron from the valence shell of an atom is called ionization energy. Now we will discuss the example of ionization energy. What is the example of ionization energy? And you clear the topic of ionization energy after see the example of ionization energy. Now we will discuss the example. Firstly, I will do the example of magnesium or sodium. Magnesium, if we remove the electron from the valence shell of magnesium, means magnesium positive plus 1 electron, and the ionization energy is required, the amount of energy is required to remove the electron from the valence shell of magnesium is 735. This energy is required to remove a 1 electron from the valence shell of a magnesium atom. And if we discuss the sodium atom, Na positive plus electron, and this energy is required to remove electron from a valence shell of a sodium is 496 kilojoule per mole. Similarly, kilojoule per mole. It is clear? Now if we will discuss the structure of magnesium and structure of sodium. Now I will try to understand this topic. What it is the energy of first ionization energy. What is first ionization energy? First ionization energy means the 1 electron removed from the valence shell of an atom. Now if we remove second electron from the valence shell of the same atom, then what is the energy required to remove this electron? Second ionization energy is greater than first ionization energy. Reason? Now we will discuss the reason. Firstly, I will try to understand this topic. What is first ionization energy? First ionization energy. What is first ionization energy? I will try to just only simple listen to this definition. Similarly, same definition of this ionization energy means the amount of energy required to remove the electron from the valence shell of an atom is called first ionization energy. I will try to what is second ionization energy. Second ionization energy. What is second ionization energy? The amount of energy required to remove the second electron from the valence shell of the same atom is called second ionization energy. I will write this definition. The amount of energy required to remove second electron of the same atom is called second ionization energy. I means ionization and E means energy. And we will discuss the second ionization energy example. What are the examples of second ionization energy? Similarly, first magnesium positive, and then second electron removed from this atom, then the second ionization energy is positive 2, means 2 electron remove this atom, and this energy is 1469 kilojoule per mole. Means now we will see it is the 735 energy required to remove first electron, but when we remove second electron from same atom, then we require the energy 1469 kilojoule per mole. It is the huge difference between them. What is the reason? It is the reason that I will discuss this reason. And firstly I will discuss the second example of sodium positive 2 plus electron and 1450 kilojoule per mole energy required to remove second electron from same atom. It is also the huge difference from them. Now we will discuss this reason. What is the huge difference? Why is the huge difference between them? Firstly, I will discuss the sodium. We know that sodium has its atomic number is 11. Now I will discuss the structure of sodium. Structure of atom of this sodium. We know that center of an atom is nucleus, and first shell have 2 electrons, and second shell have 8 electron, 3 4 5 6 7 and 8. 8 plus 2 total 10, but is the atomic number is 11. Then move this 11th electron in third shell, means this. Okay, this structure of sodium and atomic number is 11. We know that the center of atom is nucleus, and the proton is also 11 in the nucleus, and neutron is also 11 in the nucleus. Now firstly we will move the 1 electron. Okay, if we move the 1 electron from this valence shell, now we see that the remaining electrons are 10, but the proton and the neutron have same numbers, means protons have 11 and similarly neutron are 11, but the electrons are 10, means proton and electrostatic force are stronger than sodium 11. Okay, now 10 electron remaining in the sodium Na positive. Now the electrostatic force of attraction is strong between nucleus and electron. That's why the second electron removed from this atom is difficulty than that of first electron. It is the reason of huge difference between them, first and second ionization energy. Now we will discuss the trend of ionization energy in periodic table. What is the trend in periods and what is the trend of in groups of periodic table. Now we will discuss the trends of ionization energy. Now we will discuss the topic of trend of ionization energy and trend of ionization in period and in group. Firstly, we will discuss the trend of ionization energy in period. Ionization energy is greater when we move from left to right in period. Okay, ionization energy value is greater when we move from left to right in a periods of a periodic table. We will discuss the example and what is the reason of this, why ionization energy value why ionization energy value is greater when we move from left to right in periods. Is value is greater when we move from left to right in period. Now we will discuss the reason why the value of ionization energy is greater when we move from left to right in period. Firstly, I will write the elements of periods carbon, nitrogen, oxygen and fluorine. It is the second period of periodic table. First element is lithium, second is beryllium, then boron, carbon, nitrogen, oxygen and fluorine. And this atomic number is lithium 3, beryllium 4, boron 5, 6, 7, 8 and fluorine has 9 atomic number. And now we will discuss the reason why the value greater of ionization energy when we move from left to right. Firstly, I will discuss the boron atomic structure. B5, central is nucleus of an atom and the first shell have 2 electrons and this second shell have total 8 electrons, but boron has 3 electrons because its atomic number is 5. Okay, it is the 5 electrons of boron at this atomic structure of this. Now when we remove the 1 electron from this shell, okay, and compare, and I compare this oxygen atom then you understand this topic quickly. Oxygen atomic number is 8 and its atomic structure is this. First shell have 2 electrons and second shell has 6 electrons. 6 plus 2 equal to 8 electrons. And then I will discuss the fluorine atom and this atomic structure. This first shell have 2 electrons and second shell is 7 electrons. 7 plus 2 is equal to 9. This fluorine atomic number. And this structure and boron have this structure. Now we will see that second shell have 3 electrons boron, oxygen have 6 electrons in second shell. Similarly, fluorine have 7 electrons in second shell. Shells remains same, but the number of electrons are greater when we move left to right. Boron, then oxygen, we move left to right, and valence shell or shells remaining same, but the electrons quantity is greater. Now we will remove the electron is easy than this. Why? Because its valence shell have 3 electrons and its nucleus attraction just on 3 electrons, but oxygen have the nucleus attraction on 6 electrons. Similarly, fluorine nucleus, the attraction of outermost shell electrons on 7 electrons. Okay, this electrostatic force of nucleus on electrons is weakly than this. Similarly, when we move from left to right, its electrostatic force of attraction is stronger. That's why the ionization energy value is greater when we move from left to right. Why is greater? First reason is the electrostatic force of attraction between nucleus and outermost shell or valence shell is greater when we move from left to right in periods. I will discuss this reason. First, the attraction of nucleus is greater on valence shell electrons when we move from left to right. Okay, this is the reason. Now we will discuss the trend of ionization energy in group. Ionization energy value is less when we move from top to bottom. Trend of ionization energy in group. Ionization energy is value is always less when we move from top to bottom in groups of a periodic table. Now we will write the elements, name of elements in our first group. First group, first name of element hydrogen, lithium, sodium, and this first group name of elements. Hydrogen has 1 atomic number, lithium has 3, sodium 11, 19, and so on. Now we will discuss the reason why the value is less than from top when we move from top to bottom. Now we will discuss this reason. Firstly, I will take hydrogen element and this atomic number is 1, and I write this atomic structure. Center is nucleus of an atom and the first shell has 1 electron of hydrogen, and the second is sodium, has 11 atomic number, and this atomic structure, first shell has 2 electron and second shell has 8 electrons and third shell is only 1 electron. Similarly, when we write the structure of potassium and this atomic number is 19, center of atom is nucleus and first shell is 2 electron and second shell is also 8 electrons and third shell has 9 electrons, 6, 7, 8 and 9. Now we will compare these atoms. Firstly, we will discuss the hydrogen atom. Hydrogen has only one shell and only one electron. That's why the nucleus attraction of an electron is stronger. But now we will discuss the sodium valence shell electron is the force of attraction is nucleus and valence shell electron is weakly because shell also present in third shell, means third shell nucleus attraction has third shell is less. Reason, that is the reason first and second shells have remaining in third shell, means first and second shell resistance create from the attraction of nucleus and valence electron. Similarly, we will discuss the potassium atomic structure. Similarly, potassium has third valence shell, but the force of attraction of nucleus and valence electron is also weak because the two valence shell resistance create in the nuclear attraction force. That is the reason when we move from top to bottom, its ionization energy is also less. Okay, now I will teach you this topic properly and clearly, and our topic is finished and in this. And now we will discuss the next topic inshallah next day. Allah Hafiz.